Okay, so today we're doing starting chapter 10, Systems of Linear Equations. There are three techniques for solving systems of equations that you've done before in Algebra 1 by substitution, elimination, and graphing. So this first one is just like a review of how you do each of those techniques. So first we'll solve by substitution. So to solve by substitution, you pick your two equations and you solve one of the equations for one of the variables. It doesn't matter which one you choose. I would choose the easiest one. So I'm going to look at these two equations and I'm going to choose to solve the second equation for x. So I have x equals negative 4y plus 7. So again, it doesn't matter which one you choose. Once you've solved it for one of the variables, you plug it into the other one, right? So you have 2 times negative 4y plus 7 minus y equals 5. And then we're going to solve. So negative 8y plus 14 minus y equals 5. Negative 9y equals negative 9. Y equals 1. I've solved for one of the variables. Now I'm going to plug it in and get the other one. So I get x equals negative 4 times 1 plus 7, which is negative 4 plus 7, which is 3. So my solution, I have two lines right here. The two lines are going to intersect in a point. So my solution is the point 3, 1. Okay, that's the answer for that one. So my next way that I'm going to solve this is by elimination. So if you remember back to solving by elimination, you want to eliminate one of your variables. So you look at your equation and see which one would be easy to eliminate. I'm going to choose the y's to eliminate because they are opposite signs already. So I have a negative y and a positive y. So I can just add the two equations and make them cancel out. Obviously, I can't do that yet. I have to multiply the top equation by 4. So I'm going to multiply this equation by 4 so that the y's have the same number. You get 8x. Let's fix that. 8x minus 4y equals 20. So that's my first equation. So I have 8x minus 4y equals 20. And then x plus 4y equals 7. Now if you add those two equations together, the 4y's are going to cancel out. And you get 9x equals 27. X equals 3. Plug that into either equation. I'll probably plug it into the top equation just because it looks easier, but you can choose whichever one you want. So you have 2 times 3 minus y equals 5. 6 minus y equals 5. Negative y equals negative 1. Y equals 1. So again, I have the point 3, 1 as my solution. So both of those worked out. Got the same answer either way. I can choose either way to do it. It doesn't matter. And now to solve by graphing. So I'm going to rewrite my equations down here by the graph. My equations are, let's put the graph up. Okay, my equations are 2x minus y equals 5, x plus 4y equals 7. So you notice that the answers, we already know what the answers are. Those answers are a point. So these two lines should intersect in one point and I should get one answer. So this first one, I'm going to put in slope-intercept form. So I have negative y equals negative 2x plus 5. Y equals 2x minus 5. So I have negative 5 and then a slope of 2. It's important to be accurate on these because you're looking for where they intersect. So if you're not accurate, then your intersection could be off. So my line is not perfect, but we know where the points are because I put all the points up there. Now this next one is not going to be easy to put in slope-intercept form, right? So if I try to put this one in slope-intercept form, I get 4y equals negative x plus 7. Y equals negative 1/4 x plus 7/4. Okay, so that's not really a good way to graph this because 7/4 is not going to be a really accurate graph. but the slope is good, right? So -1/4 for a slope is a good slope. I only need to find a point on that graph, right? Any point on that line, and then I could do the slope from that point, right? The slope is the same through all the points. So I'm looking at my equation right here, and the easiest point that I see is probably going to be the x-intercept, right? So remember our cover-up method to find the x-intercept, you make the y 0. So if I cover up the y, then I get x equals 7. Let me erase that so it's not so messy. So I have an x-intercept of 7. 1, 2, 3, 4, 5, 6, 7. Here's my x-intercept. And then the slope is -1/4. So I can go up and left, or I can go down and right. So I'm going to go up 1, left 4. 1, 2, 3, 4. So we've already found our intersection point. But here's my line. And we intersect right here, and that point is 3, 1. So we have found the same answer in all three ways. Now, pros and cons of the technique. Graphing, if you don't have good lines, like good points, if they intersect at a fraction, it's going to be really hard to tell what that fraction is. So graphing kind of is harder sometimes. Elimination and substitution are really kind of interchangeable at this point. Substitution, if you don't have, like if you can't get the variable by itself very easily, if you end up with fractions, it could be harder. Elimination, you have to multiply. So really, it's kind of up to you which one you choose, but you can do either one. So on the next page, recall that the system of linear equations in two variables can have one solution, no solution, or infinitely many solutions, and we want to kind of see graphically what those are going to look like. So one solution we just saw, right? You have a graph. Whoa, sorry about that. There. We saw that if you have one solution, they're just going to intersect. You have two lines right here on your graph. They're going to intersect in a point, and that's going to give you your one solution. Oops. No solution. You're going to have two lines, and they're never going to intersect, so they're going to be parallel. This is going to have no solution. You'll never find an intersection. They're parallel lines, which means they have the same slope, different y-intercepts. And then infinitely many solutions, it's going to end up being one line. So your two equations are going to simplify down to end up at the same line. So that's going to be infinitely many solutions, and your solutions are every point along that line. So they're infinitely many. It's not all real numbers because like this point right here is not going to be a solution to my equation, right? It's only going to be the solutions on the line. A system with no solution is said to be inconsistent. It doesn't work. A system with infinitely many solutions is called dependent because it's dependent on, each point is dependent on the relationship it has on that line. So for this one, let's find our solutions to the equation. I'm going to use elimination because I like elimination, but you can use whichever. So elimination, if I multiply this one by 3, I'm going to eliminate the y's. And if I multiply this one by 2, then we can eliminate. So 8 times 3 is 24, minus 6y equals 15. How about 24x? There you go. And then negative 24x plus 6y equals 14. Okay, so I'm actually eliminating the x's and the y's on this one. Surprise, surprise. So I eliminate the x's, I eliminate the y's, I get 0 equals 29. That never happens. 0 cannot equal 29. So this one has no solution. Whoa. Let's go back down. There we go. No solution. I-O-N. So it is an inconsistent system. So you can write inconsistent if you want. Okay, so we have one more 2x2 system, so let's do this one. Hopefully we can get it done in this video. All right, so let's do it again. Find all the solutions to the system. I'm going to multiply the top row by 4 and the bottom row by -3. So I get 12x minus 24y equals 48. And then I get negative 12x plus 24y equals 48. So these are going to end up being the same line, right? They simplify down. You could have divided everything by 3, right? If I did that, I get x minus 2y equals 4. And then divide everything by 4 here. You get x minus 2y equals 4. So you can see that I have the same thing. If I graph this, negative 2y equals negative x plus 4, so y equals 1/2 x plus 2. So if I graph this, and I'm doing this because now that we have infinite solutions, the new Algebra 2 way to do it is to write how these are dependent upon each other. So I need to find all the solutions, so I need to know how they depend on each other. So I have this line, this is a -2. Whoops. Let's try that again. Okay, so I have a y-intercept of -2 and a slope of 1/2. So notice that all of the points along this line are solutions. So I need to write how these are related to each other as my answer to the problem. So this has infinite solutions. I have the line y equals 1/2 x minus 2. So I'm going to let x equal t. So my solution is t and then 1/2 t minus 2. So this gives me anything that I plug in for t is going to give me, so let's say I plug in 1 for t, because it's infinite solution. So the domain of this is -infinity to infinity. I can plug anything in for t, right? So if I plug in 1, then, or how about I plug in 2, because it'll make it easier. If I plug in 2 for t, so I'm plugging in 2, that's this one right here, then 2 times 1/2 is 1, minus 2 is -1. So that point is along the line. If I plug in 4 for t, right? If I plug in 6 for t, it's going to give you all of those points along the line. You didn't have to do it with x. You could have done it with the y. So another correct answer for this, you have the equation x minus 2y equals 4. So what if I let y equal t? I have x minus 2t equals 4, x equals 2t plus 4. So I could have said 2t plus 4, comma t, and that's correct also. Either one of those are correct relations for, or relationships for this answer. And now I can plug in anything for my t, because my range is also -infinity to infinity, and get every point along the line. So whenever you have infinite solutions, you have this extra step that you have to do now. Okay.